Okay, so let's look at example 1. It says for us to consider the two polynomials p of x and q of x, and it asks us to find different values based on those. So we're going to use green for p of x, and we're going to use blue for q of x. A asks us to find what p of x plus q of x is. Well, we need to just add these two together in order to do this. So p of x is 5x cubed minus 2x squared plus 7. Now notice that I'm using brackets here. Now, this is something that you're going to want to at least think about. It's not always 100% necessary to use brackets, but it's helpful. Excuse me, this is plus. It's helpful in case there is some sort of meaningful operation on it. What's really going on here is that each of these parts, the p of x and the q of x, they're being added together with a multiple of 1. And so there's really no multiplication. There's no sign switching or anything. So it doesn't actually get affected here. Like our 5x cubed is still that. Our negative 2x squared is still that. Our positive 7 is still that. And this positive 1 multiplies out to all these other 3, so we still end up with a positive 3x squared, a positive 8x, and a negative 6. And when we put all this together, we find our common denominator, or not our common denominators, our like terms. 5x cubed comes together, our negative 2x squared and our positive 3x squared comes together to make a positive x squared. We have a positive 8x, and we have a positive 7 and a negative 6 makes a positive 1. Now, we also could run into a situation like where we have p of x minus q of x. Now, how does this differ? Well, again, we have our green and our blue. So p of x, like before, we have 5x cubed minus 2x squared plus 7. But we're subtracting away the entire q of x. So not just the 3x squared, but all of q of x we're subtracting away. So that's why for this one, we want to use brackets. We almost have to, unless we distribute as we go. So like before, the p of x is positive 1. There's positive 1 of them. So we can just rewrite it exactly as it was. But the q of x is being multiplied by a negative 1. And so each of these terms needs to be flipped. Oops. So we end up with a negative 3x squared and a negative 8x, and now a positive 6. And when we combine our like terms, we end up with something different. Up here it should be a... Okay, we're good. So we end up with a negative 5x, or negative 5x squared. We end up with a negative 8x, and we end up with a positive 13. So it doesn't look that different, but it is a different answer for each part of these. Now part C asks us to find the value of p of 3 plus q of 3. Well, p of 3 plus q of 3 is the same thing as p plus q of 3. Right, we've already found this number. We've already found this function. So what we need to do is we just need to plug the 3 into our function that we found for p plus q, this one right here. Okay, so if we plug our 3 into this, we're going to get 5 times 3 cubed plus 3 squared plus 8 times 3 plus 1. Everywhere there is an x, we replace that x with a 3. Now this is important that we're not cubing the 5x up here. We're just cubing the x. The 5 is being multiplied out front. So we need to just go through and evaluate this. So we have 5 times 3 cubed is 27. 3 squared is 9. 8 times 3 is 24. And we have a positive 1 at the end. Okay, so 5 times 27 is 135. Then we add the end. This stuff we can put together really quick. That's going to make 35. And so all in all, we get 170 as p plus q of 3. And part D says, what's the degree of p of x plus q of x? Well, a degree is what is the highest or the greatest exponent of a polynomial. Well, if we look at our exponents, we have x cubed, we have x squared, we have x to the first, right? That's invisible. We don't write that. And then technically this plus 1 is x to the 0. So it's the highest of all of the exponents of x, and that is going to be 3. So part D is the degree of p plus q of x is 3. And that again is because we have an x cubed, and the cube is the highest exponent for our polynomial.